here. I'm happy to introduce Shahab, speaking now to us from Oxford. He is director of the Architectural Engineering Research Group there, and we will hear insights about LCA analysis. Shahab, the floor is yours. Okay.
Hello, everybody.
Yes.
I hope you can hear me.
Yes.
Okay, perfect. Thank you, Daniel, for the introduction and also for allowing me to be part of this event. So as Daniel has already introduced, I'm Shahab Resalati from Oxford Brookes University, and we have been part of the INNOVIP project, the partner responsible for life cycle assessment and life cycle costing in the project. So I will start with, if you can give me the control, Daniel, that would be great. Okay, I still don't seem to have control.
Okay, I'm sorry, we have this activated here. You should be able to move the mouse and...
Okay.
Yeah, yeah. No, it's working.
Yeah. Okay, perfect. It's working now. It's working now. Yeah. So I'll be talking about the common challenges and threats of data uncertainty for innovation projects. So I'll start with an introduction into life cycle assessment, and then I'll talk about the challenges and shortcomings of the current methodologies and standards out there in practice, and then discuss what our approach was in INNOVIP project. And at the end, I will also mention the activities that have already taken place as part of the AMANAC cluster in this regard. So LCA analysis generally, in terms of its objectives, is intended to transparently and accurately and independently verify and communicate environmental impact of different products and services to the end users of this analysis. It needs to be, conducted in compliance with different standards and codes depending on the industry that we're dealing with. Within the construction industry, there are a number of well-known standards like 14040 and 15804, which looks at environmental product declarations and things like that are well known. What I'll do very briefly, I will explain the life cycle analysis and its components, and then I explain in detail later on in the presentation how we have dealt with different parts of this process. So it generally has four main components to it. One is the goal and the scope definitions. It's basically where you define the goal of this study, and then you talk about the boundaries that are going to be studied as part of the process. What are the functional units? The reference flows. What goes into the product and what goes out of it as part of as part of the process. And then we'll be talking about the life cycle inventory, which is basically the emissions and resources quantification when it comes to LCA analysis. And then we'll have the life cycle impact assessment, which is basically transferring the data from the LCI step into representation of environmental and human health impacts. This whole process finalized at the end by interpretation step, that you talk about the results and see the implications of the analysis for different end users and how this can be used, and depending on different applications, then you can apply uncertainty and sensitivity analysis also to the process. the users of LCA can easily cover a very broad spectrum of stakeholders and end users. If we want to generally categorize the end users into 4 different groups, we can talk about the process and product developers, people who are interested in the environmental considerations of their products and services, then the consumers, the end users, and the people who are responsible for supply chain management and procurement, that are also interested in the environmental impact of things. And at the end, the regulators and policymakers will go to that point in more detail later on in the presentation. The LCA at the moment and currently, the way it's being used in practice, there are a number of technical and methodological challenges that we face that need to be addressed as soon as possible. And I will be explaining very briefly, we're using case studies, why this needs to be addressed very urgently. Is that so the number of technical and methodological challenges that I have summarized for this study is mainly related to the availability of data. So how do we make sure that the data is reliable and accurate? The data can be, simply not existing, or for confidentiality reasons, the manufacturers might not be willing to share data. So LCA, as you all know, is a very intensively data-driven approach. So we really need access to data for it. It can also be related to inconsistency in parameters of assessment. So different people and different LCA practitioners will look at different system boundaries. So it means that the parts of the process that will be reflected in the LCA study might differ from manufacturer to manufacturer and from practitioner to practitioner. So that also is an important factor to be taken into account. And the life cycle inventory techniques also can differ quite significantly. So we generally have 3 LCI techniques. We have the process-based, we have the input-output based, and then hybrid methods. So process-based, just very briefly, breaks down the life cycle into different processes, and then anything outside the system boundary is not taken into account in this method. And this is known to suffer from truncation error, as basically means that you're underrepresenting the requirements. And then we have the input and output method that we basically use all the financial transactions between sectors and then assign energy and carbon intensity to these transactions. So this is also suffering from an error called aggregation, because within a similar sector we assign the same energy intensity to all transactions. So these are all addressed or tried to be addressed in another method called hybrid method that is trying to covering the pros of each process into account. So looking at these different methods, I don't expect you to read all these words. So the reason I have included it here is that if you just compare the studies that have taken these different processes into account, different techniques into account, their studies have shown huge differences and discrepancies between results. So 4 times, double, 159%, 100%. So these are all the gaps between when we use these different between the data and results when we use these different techniques when it comes to LCA. So these discrepancies can simply draw attention to what are the implications of these for the end users, and specifically in our conversation, the construction industry. Sorry, I'm rushing through some of the slides, so I'll have more time when I talk about INNOVIP. So people have looked at several techniques and methodologies in order to reduce the uncertainty. So they have looked at sensitivity analysis, they have looked at scenario-based and simplification methods. And you know, try to address this issue. Despite all that, we all know that this is the future. We need to know the environmental impacts of the steps we take towards building products and services and our built environment generally. So we need to make sure that we can provide scenario-based analysis and can create and generate clear and simple messages to the end users of the LCA analysis so that it can be used ideally as a decision-making tool. I briefly explained our approach in the INNOVIP project. So INNOVIP as a project has been, you know, presented in the previous presentation. So I'm not going to explain about INNOVIP anymore. So our approach in INNOVIP was that we have taken a total carbon methodology approach. So basically, looking at this graph, what it's showing is that on the x-axis, as you add to the thickness of insulation, the operational energy of your building reduces. Of course, it's because you are improving the thermal performance of your building cladding and building element. So as you do that, as you use more insulation, you're also adding more material into the building. So as the thickness increases, the green line is showing that the embodied energy also increasing. And when you put these two lines together, you'll get to a point on the graph, you know, the blue line. You get to a point on the graph that actually beyond a certain point, you're adding to the carbon intensity of your building rather than reducing it, because the operational savings cannot offset the embodied energy investments. So this is, you know, then translated into this graph on the right hand side of the screen, that you can see that if you take you know, the little circle in the middle as the absolute lowest on the graph, absolute lowest point in the graph, and the two sides of the colored you know, panels, you can see that the two sides of the arrow are showing the same energy sorry, the same carbon intensity value for 100 mil and 300 mil insulation, because, you know, the overall carbon intensity is increasing, is starting to gradually go up after that absolute minimum on the graph. Sorry, I've lost my control on the slides. Oh, right, okay, back please. So we have looked at this issue using several different insulation materials that are commonly used as mainstream insulation materials in the construction industry. And you can see that depending on the source of data and how you analyze and which point you know, on that data you use in your analysis, you can easily see a very wide spectrum of energy values, depending, you know, the large spectrum of energy values on your final LCA result. And for example, you know, taking, you know, any of these, the vacuum insulation, as we're talking about it, you can see that the difference in the results can be really significant. So we have then translated this into optimum U value points, you know, the total you know, conductance through the building elements. And you can see that depending on what points of data from different manufacturers and environmental product declaration you take, and you take into account in your analysis, you can see that the optimum point on the graph can be very broadly different. And that really asks the question that, you know, how efficient and how reliable our LCA analysis can be when it comes to be used as a decision-making tool. So how can we make sure that the analysis is used in a way that can inform the decision makers in a way that they can make reliable decisions about their businesses or their products or services. So what I try to explain here is to raise this very challenging question that how do we ensure that we use LCA as a decision-making tool very reliably. There are a number of things that we need to address. We need to make sure that the fundamental methodological inconsistencies are addressed. We need to make sure that what we produce to inform policymaking is transparent and reproducible. We need to be aware of the uncertainties associated with data and conduct and undertake studies and activities that can reduce the amount of uncertainty and reduce the implications of the data uncertainty for different end users. We have already started this process of understanding and identifying these different processes as part of an AMANAC cluster. We have organized a session, workshop session in Vienna as part of the Industrial Technology Conference, and have started, bringing together people, different experts in the LCA industry to talk about the implications of data uncertainty, how we can use LCA as a decision-making tool. An effective adoption of LCA as a decision-making tool requires a collective collaboration from all of the stakeholders. So I do invite all of you to contribute and join the LCA community for all of us to be able to address these issues together. Sorry, I have done a few seconds more than what I was supposed to do. Thank you for
wonderful. Thank you, Shahab. Thank you so much. We will now invite all the previous speakers for the upcoming Q&A session. And Caroline, do you already have one question for Shahab?
For Shahab, there is nothing at the moment. Everything seems to have been clear. Maybe something else will pop up, but then I will come back to that later.